In the previous topic, we were able to discuss about the substitution method, which is one of the basic techniques of integration. Then we were able to give some examples and exercises. Okay. Now this time we are now ready to discuss about integration by parts. Then we'll be giving examples and exercises. So, what is integration by parts? Integration by parts is a rule that transforms the integral of products of functions into other functions. Just like the substitution method, it can be used if you are given product of two or more functions. Now, if the functions are not related, then we can use integration by parts. Just like the substitution method, we have a clue that if the given function is product of two functions where one is composite and the other is the derivative of the innermost function, then we can use substitution method. But this time, one clue to use integration by parts if the functions are not related to each other. So what's nice here is that we are already given the formula for integration by parts. So the formula is integral of u dv is equal to uv minus the integral of v du. In other words, if we're given functions and we can rewrite that function into the form of u dv, then we can use the equivalent of the integral of u dv, which is equal to uv minus the integral of v du. So to understand more on the integration by parts, we have this example. So find the indefinite integral, that is the integral of x cosine x dx. So the first thing to do is to choose what is your u and what is your dv, because if we go back to the equation, we need to rewrite the given function into the form of u dv. Then if we already have u dv form, then we can use this formula, which is equal to uv minus integral of v du. Okay, so as you can see, we have product of two functions, the x and the cosine x. Now this is one clue because x and cosine x are not related to each other because x is an algebraic function while cosine x is a trigonometric function. So we need to choose our u. Now, if I choose my u, which is equal to x, I choose u, which is equal to x, because it's simpler, okay? But we have to take note that sometimes choosing the simplest function will not work. So all we have to do is just to choose our u and dv carefully. So I choose my u, which is equal to x, and dv, which is equal to cosine x dx. Okay, now after choosing this, what are we going to do? After this, we need to find the derivative of u with respect to x. Now take note, the derivative of u with respect to x is just du dx is equal to 1, right? So du dx equal to 1, which is equivalent to du is equal to dx. Okay, from here, this becomes du dx, which is the derivative of this. Now we have dv, which is equal to cosine x dx. Because if we recall, what we need is uv minus integral of v du. So we need to look for u, look for v, and v du, right? So since we are given dv, which is equal to cosine x dx, so all we have to do is to find v. Now how to find v is to integrate this dv is equal to cosine x dx both sides. So integrating both sides, integral of dv, we have v, then the integral of cosine x dx is equal to sine x, right? Sine x. So we have already the u, which is equal to x, du is equal to dx, dv is equal to this, and v is equal to sine x. So this means that our integral of u dv, again, this is the formula, is equal to uv minus v du. So since we have our u, okay, what is our u? Our u is x. So we write x here. What is our v? Our v in terms of x is sine x. So x times sine x minus the integral of v du. What is v? V is actually equal to sine x and du is equal to dx. Okay? So if we are going to look at this equation, this is already of the form or in terms of x, right? So we need to simplify and we need to solve the integral of sine x dx here. Now, the integral of sine x dx, so this means that the integral of x cosine x dx is simply equal to x times sine x minus the integral of sine x dx. Now, the integral of sine x is negative cosine x. Then don't forget to add c. So this is equal to x times sine x, and negative times negative becomes positive. So we have x sine x plus cosine x plus c. So this is our indefinite integral of this problem. Okay, so we are done with the first example. We move on to the second example. So example 2, find the indefinite integral that is given by integral of x times e raised to 3x dx. So the first thing to do is to look at the two functions or the product of two functions. X is an algebraic function and e raised to 3x is an exponential function. So they are not related to each other. So therefore, maybe we can use integration by parts. So using integration by parts, we need to choose our u dv, right? So I choose my u, which is equal to x, because it's a simpler one compared to e raised to 3x. Then I choose my dv, which is equal to e raised to 3x dx. What's next is to find the derivative of u with respect to x, that is du is equal to dx, right? Now finding v, we need to integrate this equation both sides. So integral of dv is v. Integral of e raised to 3x dx is simply equal to 1/3 e raised to 3x. Okay? Then using the formula of integration by parts, we have integral of u dv is equal to uv minus integral of v du. So we start with our uv. What is our u? Is x. What is our v? Our v is 1/3 e raised to 3x. That's why we have 1/3 e raised to 3x minus the integral of v du. What is our v? Again, is 1/3 e raised to 3x, and our du is dx. That's why we have integral of 1/3 e raised to 3x dx. So we need to find the integral of this to simplify the whole expression. So what is the integral of this? Okay, now take note that 1/3 is constant, so we can write 1/3 and we can put it outside or beside the integral symbol. So we have 1/3 times the integral of e raised to 3x. And take note that the integral of e raised to 3x is just equal to 1/3 times e raised to 3x. Then do not forget to add c here to represent all the constants. So we copy this one. We have 1/3 x e raised to 3x. Then we also have 1/3 times the integral of e raised to 3x, which is equal to 1/3 e raised to 3x plus c. Then to simplify that one, we have 1/3 x e raised to 3x, and 1/3 times 1/3 is 1/9, then e raised to 3x plus c. Okay, so that is the answer, and that is the indefinite integral of the given problem. So hope you learn from this video, and don't forget to share the learning that you've got from this video. And if you have more questions on the examples that we had, don't forget or don't hesitate to comment your concern or comment your questions in the comment section. See, okay, thank you so much. And we have here the exercise. So if you want to practice more on um, integration by parts, so I provide you with this exercise. So if you want to know the answer, just comment your answer in the comment section. So we have integral of x times e raised to x squared dx. So again, you need to solve this using integration by parts. Okay, so that's it. Thank you so much um, for watching this video. Hope you like this video, and don't forget to share the learning that you've got from this video. Once again, thank you so much and God bless.